In this video, we will discuss arc length and area of sectors. First, let's review some key terminology. The arc length is the length of an arc, and it's a fraction of the circumference. So in this diagram, the arc length is the length of this part of the circle, as if we were to take a tape measure or something and measure it. The area of the sector is the area of that specific sector, like a section of the circle, and it's a fraction of the area. So this area of the sector is the area of this piece of the circle. Now for our arc length, since it is a fraction of the circumference, we can set it up in a proportion with the measure of the arc. So we can set it up as the arc or angle measure in degrees over 360 equals the length or circumference, the arc length over the circumference, as given here. And I would copy this formula down your notes. And again, we know the circumference is already 2 pi r, or pi times diameter. So if we're going to model this with the example shown below, the arc or angle measure is the value of n over 360 equals the arc length, which is this value of s, over the circumference, which you can either treat as 2 pi r or pi times the diameter. The formula for the area of a sector is very similar, except for now it's a fraction of the area. So the arc or angle measure in degrees over 360 equals the sector area over the circle area, which we know is pi r squared. So if I were to set it up for the example shown below, I could set up my proportion. It's the angle, which is n, over 360 equals the sector area over the area of the circle, which is pi r squared. So in this example, it asks us to find the arc length and area of the sector. So first, for arc length, we know that the formula is it's the angle over 360 equals the arc length over the circumference. Now we know from the diagram that the angle or arc is the measure given here. So I can write it as 150 over 360 equals the circumference we can determine is 2 pi times 8, so it equals 16 pi. So I'm using that radius, so I can fill in my circumference in the denominator. So I put 16 pi, and then the unknown you're solving for, you can use whatever variable you'd like. So I'm going to use x in this case. So now if I wanted to solve, I would have to cross multiply. So I'd get 360 x equals, we multiply the 150 times the 16 pi. So it becomes 360x equals 150 times 16 gives us 2,400 pi. And then if we divide both sides by 360, it gives us 6.6 repeating, which if I simplify as a fraction, becomes 20 pi over 3 yards. Now for the area of the sector, remember we use the angle over 360 equals the area of the sector over the area of the circle. So the angle is still the 150 we identified before. So it's going to be 150 in the top over 360, and the area of the circle is pi r squared, so it'll be pi times 8 squared, which is 64 pi. So I can put 64 pi in the denominator, and then my numerator is what we're solving for, which in this case is the area of the sector, which I'm going to call y, so I use a different variable, so I'll have a y on the top. Now I have to solve by cross multiplying, so you get 360y equals, and multiply the 150 times the 64 pi. So 360y equals 150 times 64 gives us 9,600 pi. And then if you divide both sides by 360 and simplify, it becomes 26.6 repeating, which we change that to a fraction, gives you 80 pi over 3 yards squared, because it's area. So for our next example, for the arc length, we're still using our same formula. So if I set up my proportion, we know that the angle is 300. So we can put 300 on the top over 360. And the circumference we can calculate using the radius of 3. So we know the circumference equals 2 pi times 3. So it gives us 6 pi. So we can fill in 6 pi in the denominator. And then my unknown arc length, I'm going to treat as x. So I'll have an x in the numerator. Now, if I want to solve, I have to cross multiply. So you can multiply the 360 by x. So you have 360x equals, and the 300 by 6 pi. So if we do that, you get 360x equals, and then 300 times 6 gives you 1800 pi. And you divide both sides by 360, gives you that x equals 5 pi inches is your arc length. And now to find the area of the sector for this example, I can set up my proportion. So we first need the measure of the arc, or the angle, which is identified as 300 previously. So I can put 300 on the top of the numerator over 360. And then we can use the radius to find the area of the circle, which would be pi times the radius squared, which gives us 9 pi. So I have 9 pi in my denominator, and then we can choose our variable that we're solving for. So if I choose to call this y, I now have a proportion to solve. So I cross multiply, I multiply 360 times y, and the 300 times 9 pi. So I have 360y equals 300 times 9. So it's 2700 pi. And then divide both sides by 360 to get y equals 7.5, which we can change back to a fraction. So it's 15 pi over 2 inches squared, since it's area. Now let's say we are given a problem like this, where we have a sector area of 90 degrees and the area of the circle is 36 pi. Now, if we draw a picture for this, we know that we have a circle. We're talking about an area of the circle, so it has a right angle, and we know that this area equals 36 pi. The question is, what is the radius? So if I use my sector formula, we know it's the angle over 360 equals the sector area over the circle area. So in a problem like this, I can substitute. So the angle is the 90, which is shown here. So if I set up my proportion, I'm going to have 90 in the numerator over 360 equals the area of the sector, which was identified as 36 pi, and then the area of the circle, which we don't know, but using the radius, we know that it should be pi r squared. So if I were to cross multiply, I'd have 360 times 36 pi equals 90 times pi r squared. Now if I multiply the 360 times 36, it gives you 12960 pi. And for the other part, it gives us 90 pi r squared. Now if I first divide both sides by pi, the pi's cancel, so it becomes 12960 equals 90r squared. Now in order to continue solving, you'd have to divide both sides by 90. So you would get that 144 equals r squared. And lastly, you take the square root of both sides, so you get 12 equals r. So this tells us that the radius is 12 inches. The last topic in this video is the segment of a circle. So the segment of a circle is the part of the circle bounded by an arc and the endpoint. So if we are looking at the pizza, the segment of the circle is this small part of the circle as shown. So in order to find the area of the segment, you have to use the area of the sector minus the area of the triangle equals the area of the segment. Because it's like I take my whole sector and I remove the triangle, so I'm left with just the segment. In this problem, we have to find the area of the segment. So we first would start with by finding the area of the sector. So using what's given in our formula, my angle is 90 over 360 equals the area of the circle is pi times 10 squared, which is 100 pi. So it'll be 100 pi over the area of the sector, which we don't know. So if I were to cross multiply 360 times x, so you have 360x equals 90 times 100 pi. And then if I simplify, the 360x becomes 9,000 pi. And you divide both sides by 360, which gives you that x equals 25 pi. So now if we continue from here, we have to next find the area of the triangle. Now because this is a right triangle, as shown here, the area of the triangle is 1/2 the base times the height. So the area of the triangle is 1/2, the base is 10, and the height, because it's a radius, is also 10. So this gives us that the area of the triangle equals 50. Now the last part of our calculation is going to be the area of the sector minus the area of the triangle. So in this case, the area of the sector is 25 pi minus 50, and the question asks us to round our answer to the nearest tenth. So if I plug that in the calculator, 25 pi minus 50 gives us the value of 28.5 inches squared because it's area. In the next example, it also asks us to find the area of the sector. So if I were to do so, the area of the sector is going to be the angle measure, which is 144. So it's 144 over 360 equals the area of the circle, which is pi times phi squared, which gives us 25 pi. So it'll be 25 pi over the area of the sector, which we don't know, so we can call that as x. Now if we solve, you'd have to cross multiply. So multiply 360 times x, and the 144 times the 25 pi. So it gives us 360x equals, and 144 times 25 gives us 3,600 pi. And then if you divide both sides by 360, it gives that x equals 10 pi meters. So now we know that the area of the sector equals 10 pi. The next thing we need to find is the area of the triangle. So if I redraw the triangle, we know this is 5 and 5, and we know that this angle at the top is 144. However, we need to find the area of the triangle, so we're going to draw in the height. We're going to calculate 144 divided by 2 to figure out what each of those angles are. So if we plug in the calculator, it gives us that each of these angles is 72, and this is a right angle. Now we can use trig to solve using just one of the triangles. So if I solve, let's say I first choose to solve for the base. So if I redraw just this triangle, I have a right triangle with this is 5 and 72. So if I choose to solve for this part of the base first, I can set this up so this is my opposite and hypotenuse. So sine of 72 equals x over 5. And to solve, we multiply both sides by 5, making sure we're in degree mode. So 5 times sine of 72 equals 4.8, which tells us that this equals 4.8. So in the original problem, or the original triangle, this is 4.8, and this part of the triangle is also 4.8. So the whole base is 4.8 plus 4.8, which gives us 9.6. Now if we want to solve for the height, let's say I call my height h, I can use Pythagorean theorem. So 4.8 squared plus h squared equals 5 squared. And if we solve, it gives us that h equals 1.4. So this value is 1.4. So this h here equals 1.4. So now if I want to find the area of the triangle, it's going to equal 1/2 times the base, which we found is 9.6, times the height, which we calculated to be 1.4, which will give us 6.7. And now as our final calculation, we have to find the area of the segment. So the area of the segment is the area of the sector minus the area of the triangle. So it'll be 10 pi minus 6.7. And when you plug that in your calculator, it gives you a value of 24.7 meters squared.